lesson, and in this lesson we will focus on deletion, and specifically I will focus on three scenarios. One scenario, how to delete a node from the beginning, how to delete a node from the end, and how to delete a node by value. Technically, from software engineer perspective or from a programmer perspective, deleting a node from a list means removing the connection between that node with the other nodes. For example, no node has to point to that node, and that node should not point to any other nodes. That means that node is deleted. So now let's focus on the three scenarios. I create one function to delete the node from the beginning. So delete from the beginning. There is no parameter needed for that, because whenever I'm calling this method, I mean that I am deleting the first node in the list. So for example, right now, if we consider this node as our head node, which is at the beginning of this list, when we want to delete this node, what does this mean technically? Technically, it means that the head should not point to this one. And instead of pointing to this one, the head has to point to its next node. For example, right now it is this dot head. So the head should point to this dot head dot next. So when head points to this node, that means this node is removed from the considered removed from the list, like this. If we write the code for that, so we say this dot head equals this dot head dot next. That's it. Right now the head is not pointing to this node, and instead of pointing to this node, it points to this node. That means we removed this node from the beginning of the list. However, you should know that most of the time when you delete a node from the list, you are returning that node, the removed node. So in order to do that here, before removing the connection from this, let's keep this in a separate variable. Let removed node equals, so it is right now it is this dot head, and now this dot head points to the this dot head dot next. So instead of this node, it points to its next node, and here we can return removed node dot value, like this. So this easily we could remove a node from the beginning by just changing the pointer value of the head. And instead of pointing to this node, it points to the this dot head dot next. Okay, and how we delete a node from the end of a list. So first let me make this connection also. Okay, now it is removed, it is also removed. So now we have connection from this to this. Okay, now I create another function to delete a node from the end of the list. Delete from the end. So again, there is no need for a parameter, because whenever I call this function, I mean to delete a node from the end of the list. So in order to remove the node from the end of the list, we have to iterate the list from head and go until the last node. Whenever we find the node which its pointer is null, that means that is the last node. So we have to remove the connection of its immediate parent node. For example, right now this node dot next points to this node. So instead of pointing to this node, it has to point to null. So how can we do this? When we start iterating our lists, traversing our list, it is very easy to have two variables. One should be, for example, this one, previous, and one should be, for example, this one, current, previous, and current. So if both of these two iterator or counter or variables move together, for example, when the current is the head, previous is null. So when current is here, previous is one node tiers before. So we continue traversing the list until the current reaches a node that its dot next is null. So for example, when current comes here, the previous comes here. So at this time, at this point that we found the last node, so we say that this node, the previous dot next, this should be equal to null. When we make this null, that means we remove the connectivity of this node to the list. Now let's write the code for that. So I'm saying that let's create two variables. Let previous equals null, and let current equals this dot head. We start from the head. So we say while as far as the current dot next is not null, as far as current dot next is not null, it has to continue traversing the node. So for example, at this point that the current is this dot head here, current dot next, it is not null, so it continues. That means current, the previous becomes the current value, previous becomes the current value, but current becomes current dot next. Previous it was null. Now previous takes the first the value of the first node, and then the current moves one node ahead. So this loop continues again. Now the previous is here, current is here. When we check now, again current dot next is not null, so again both of them has to move one step ahead. The previous takes the value of current, and current takes the value of its dot next, which becomes this node. Again this continues, and at this time it becomes this node. So when the current at this node, the previous at this node, so this time current dot next is null. So when current dot next is null, so that means that is the last node. Now we make the previous dot next equals null. Previous dot next equals null. As easy as this. We just removed the last node from the list. So just in case you want to return the deleted value, so you have the last node in the current, so you just say return current dot value. That's it. Okay. And another scenario is when you want to delete by value. For example, a value is given, you search this node, and you want to delete, for example, 99. If you delete this node, what does that mean? That means you have to remove these pointers that are pointing to this node. Its previous node has to point to its dot next node. For example, now if this node, instead of pointing to this node, points to this one, and that means you have removed this node from the list. As simple as that. Okay, so let me write the code. Let's start again, similar to deleting from the end. We have to have two iterators. The current the current and the previous, because when the current comes here, so using the previous, we can say that previous equals current dot next. So like that we can easily remove a node from the list. So again, let's have two variables. Let previous equals null, and let current equals this dot head. Okay, so we say while current dot next is not null, it has to continue traversing our list. So if it is not null, every time we are checking its value, we are saying that if current dot value equals the value, that means we have found the node that we are trying to remove. For example, 99. When we find this one, that the value is given as matches this node, so we say that the previous dot next instead of pointing to this node or current, it has to point to current is here now, current dot next, as simple as this one. When this points to this one, that means this node is removed from the list. But if the value is not matched, so again, like you have to continue going ahead every time. The previous equals current, and current equals current dot next. Current dot next. But if it at some points current dot next becomes null and still the value is not found, so that means the node with the given value is not in the list. It has to return null. It has to return null. So it was all about deleting a node from a list. I hope it was useful, and if you have any questions, you can comment. Again, here in my original notes, you see that there are a lot of conditions are taken care of. For example, if a list is empty, or if for example, sometimes the given value matches the first node, those conditions. But this is the general rule. If you know this, that means you can take care of those conditions as well. Have a nice time until the next lesson.